Greetings to you all. Welcome to the AOS-CX 10.12 update series. I am Shobna, Technical Marketing Engineer, Aruba Campus Switching. So in this video, we will see about 10.12 update feature PoE allocate by class or usage support in LUR, TUR and VSA. Let's quickly jump into the session. So here is the agenda for today's session. We will be covering the overview, use case of the feature, details and caveats of how the feature works, how we can do the configuration, and how we can troubleshoot if there is any issue with respect to this feature, parity analysis, demo of how the feature works, and any additional resources required for this feature. First, let's see the abbreviations used in this session. So first is PoE, that is power over Ethernet. Next is PSE, power sourcing equipment. PD, that is power device. LUR, local user role. DUR, downloadable user role. VSA, vendor specific attribute. Overview. First, let's see the overview about PoE allocation in our CX switches. CX switches act as a power sourcing equipment and provides power to the powered devices. So how the PoE allocation happens in our CX switches? So there are two ways of allocation. One is allocate by class and the other one is allocate by usage. On top of these two allocation methods, there is one more dynamic way to do the allocation, that is LLDP based allocation, where the allocation is decided after the LLDP exchange between the PSC and then the PD. So when there is no LLDP negotiation happens, or if any of the device is not LLDP capable, then allocate by class and usage will come into picture. Let's see the difference between both the methods. The power allocation method is initially based on usage, that is, by default, the power allocation is by usage. In allocate by usage, the allocated power value will be the actual instantaneous power draw, and then the reserve power will be based on the actual power consumption. Next is allocate by class. The power allocation is based on the PD requested class and PSC allocated power will be based on the PD class. The reserve power is based on the PD class. So with that overview, let's see the enhancements in PoE allocation. First, prior to 10.12, the PoE allocation can be enabled only from the interface. Like we will be visiting the interface context of the particular interface and we will issue the CLI power over Ethernet allocate by class or usage based on the device type. But this becomes headache for the customer to identify the interface and then configure the PoE allocation. So if it is a port access client, they have to again go to the interface context and do this configuration. But most of the port access configuration exist in the rule. So for that purpose, we have introduced this PoE allocation for the port access clients using following ways. First is LUR, local user role, where the role definition exists in the switch. So inside the port access role context, we have introduced the new CLI option, PoE allocate by class or usage. So this can be used to configure the PoE allocation. So similar to LUR, we have this definition existing in the DUR as well, that is downloadable user role, where the role definition exists in the ClearPass policy manager. So this is the syntax of the role definition. So we can have the port access role and then the role name, and then we can configure the PoE allocate by class or usage. So there are customers who are not willing to use local user roles or downloadable user roles. They are using only the vendor specific attribute. For that purpose, we have introduced a new vendor specific attribute, Aruba PoE allocate by method. So it holds the value of class and usage. So these are the ways we can configure the PoE allocation for the port access clients. Use case. Let's hear about the use case. So what major use case this enhancement will assess? Yes, it's none other than our colorless access ports. So as we all know, the great advantage of colorless ports is admin no longer need to remember which access port end device has been connected. He can perform role-based access controls seamlessly from the ClearPass Policy Manager or any other network access control server. So now even the PoE allocation can be done via LUR, DUR and VSA based on the network access control server capability. So the admin need not be sticking to the static port configuration every time. So this PoE allocation will be one more element added to the crown of our Aruba dynamic segmentation solution. Details and caveats. Let's hear about the details and caveats of this feature. So by default, the PoE or LLDP power negotiation is enabled in the PSC and then the PD. So the PSC and then the PD will periodically send LLDP packets to each other to perform the power negotiation. So the PoE over the LLDP power negotiation starts when the PSE receives the LLDP packets from the PD. So the PD sends an LLDP packet to the PSE. It carries the power via the MDI TLV. So it contains the power supply priority of the interface and then the PD requested power value. The PSE replies with an LLDP packet to the PD device after receiving the LLDP packet from the PD device. So the PSC allocates the corresponding power to the PD device. So this is how the power negotiation happens between the PSC and then the PD via the LLDP. So when there is no LLDP negotiation, the PoE allocation is handled by usage or the class. So this feature is supported on all the Access PoE platforms listed here. Configuration. Let's see how we can do the configuration for this feature. So first is configuration via CLI. So to enable this PoE allocation LUR, here is the configuration, that is port access role and then the role name, and we have this option PoE allocate by, and it has two values, either it can be class or usage. So based on the requirement, it can be set as PoE allocate by class or PoE allocate by usage. So now let's see how to do the PoE allocation in DUR. So here is the snippet of the DUR configuration from ClearPass. Currently it is supported only in advanced mode. So in the advanced mode we can select the Aruba CPPM role BSC and provide the role definition. So here is a sample role definition with port access role and role name and given the value as PoE allocate by class. So it can be also by PoE allocate by usage as well. Configuration continuation. So let's see how this configuration can be enabled using vendor specific attribute for PoE allocation. So we have introduced the new vendor specific attribute Aruba PoE allocate by method. It is Aruba specific attribute. The type is integer and length is 4. The unique attribute ID is 70. So we can send two values for this attribute. One means PoE allocate by class, two means PoE allocate by usage. So one point to be noted is this attribute will override the PoE allocation method configured on the port. So only this takes the precedence. But we have multiple clients onboarding the same port, then only the latest client's value will be the PoE allocate by method set in that port. Let's see how we can do the configuration via REST. So what is the REST API we'll be using to create LUR for this PoE allocation? So for that purpose, we'll be using the system port access role REST API call, and we'll be doing a post since it is a creation. So this REST API call will do a creation of a LUR. So for that purpose, the request body should contain all the LUR attributes. Specifically, I have highlighted the PoE allocate by method. So it is set as a class. So this is how through REST API we can do the configuration. Next is show commands. So let's see the show commands one by one. First is to view the LUR configuration, we have to use the show command show port access role name and then the role name. So here is a snippet of a show port access role name command output. So it will clearly show what is the role configuration. So we have seen that the PoE allocate by is set as usage. So next is to view the DUR configuration. So we have to use the show port access role clear pass show command for it. So here is a snippet of it. So it will show the DUR configuration. So what is the PoE allocate by method configured? So next is to view the client details. So we have to use the show port access client detail here. So it will clearly show the role configuration as well. For this client, the role applied is a local LUR. So here it will show what is the PoE allocate by method set in that LUR. Now let's see the PoE related show command. To view the PoE allocation, you can use the show command show power over Ethernet and then the interface. So here is a snippet of how the show command will look. So it will clearly show what is the allocate by configured and what is the allocate by actual applied for the particular port. So the PoE related information can be easily viewed using this show command. So next is REST GET. So if you wanted to view what is the LUR configuration using REST API, so this is how we can do it. Like we can do a get of the system port access role and then the role name if you try to give it. And if you try to push this curl command, it will clearly show the role information in the response body. So if you could see here, the PoE allocate by method is set as class. Troubleshooting. Let's see the troubleshooting option for this feature. First is port access role assignment. Only when the role assignment is successful, then only the PO allocation can happen. For that purpose, we need to debug why the role assignment is failed or why a different role is assigned. So we can use the following ways to debug it. First is enabling the debugging. Like you can enable the debug destination as any of them like buffer, console, file or syslog, and then module specific debug port access all has to be enabled. So this debug will log all the port access feature debug events. Next is in case if you're not comfortable with the debug logs, I wanted to view only the diagnostic logs. In that case, we can use this diagdump port access basic. It will display the diagdump output of port access model. Next is PoE allocation. So once the port access role assignment is successful, but still the PoE allocation has not happened correctly as per the configuration, then we can go with the next step as debugging the PoE allocation. So for that purpose, you can use the following ways. Like you can use the diagnostic logs, diagdump PoE basic. So it will display the PoE related commands for the particular client. Based on that, we can check what is the PoE allocation happened for the client. If there is any difference in the PoE allocation later on, we can check is that a client specific issue or a switch issue. So let's see the sample output for the port access debug. So I have used the show command show debug buffer module port access, and then I have used reverse to view the debug logs. So if you could see here, the port access role assignment for the client is successful and it has been assigned with a role called AP. So this debug log will help us to identify what is the client specific role assignment happened. So if there is any difference in the role assignment with the debug logs, we can identify it. Next is diagdump output. So I have given only a snippet of how the diagdump output will look for a particular role. So here, if you could see here, this is for the port 113 where the client is connected, and the current port access role assignment has these attributes like PoE allocate by is set as usage. So through that we can identify the client connected port what is the PoE allocation has happened. If there is a difference in the PoE allocation, we need to debug like why is the PoE allocation has happened in different way. Was it the role assignment problem or is it a PoE problem? So next we will see the diagram output of PoE module. So this is a snippet of a diagram output for PoE basic. So it clearly shows the interface level PoE allocations. So what is the PoE priority and how the PoE allocation happened. So here the allocation has happened via class and the status currently is delivering, and what is the reserve power. So those information can be easily seen using this diagram PoE basic. So this is additional output available for us for diagnostics apart from the show commands. Parity analysis. Let's see whether this feature is supported in our own products as well as in our competitors environment. So first is our AOS-S switches. So this feature is supported in our AOS-S switches, and here is the CLI for it. So AAA authorization user rule, and if you go to the user rule context, there is a device specific PoE allocate by class available. By default it is usage, so they have given only PoE allocate by class as an option. So next is with our combat switcher. This feature is not supported there. And next is with the Cisco switches. So Cisco does not support this user role based PoE allocation. Demo. So here is the topology I'll be using for the demo. It is a 3-level topology with access switches connected to the aggregation to core, and then the service layer comes in. In the access switch I have connected two endpoints. The one is a AP and other one is a phone. So both are PoE enabled devices. So let's see the configuration. So the configuration will be simple. I'll be creating a colorless port configuration for all the ports where the security is enabled. So the port configuration is same everywhere. I'm just using MAC authentication for this demo. So I have enabled only MAC authentication. So next is the role configuration. For the AP, I am creating a role called AP with auth mode as device mode and PoE allocate by class. And for the phone I am using a user role named as phone, and then here the PO allocate by usage, and then I am using a VLAN trunk. So let's jump into the demo. So here is the switch console. I will do a show version to confirm the image running on the switch. It is in 10.12 version. So let's see the LLDP neighbors. So I have two end devices connected in port 3 and 4. So let's see what are those devices. So first in port 3 I have a IAP 505 connected. Next in port 4 I have a telephone connected. Let's see what is the interface level configuration of these end devices. So these end devices are in default port configuration. So now I will create two rules. So one for the AP, the other one for the phone. So in the AP rule I have made PoE allocate by as class. So next in the phone rule I will try to allocate by usage. So here the PoE allocate by is set as usage. So now what I will do is I will go to the phone interface, that is the fourth port. So in this interface I'll try to configure the power over Ethernet is allocate by class instead of default usage, because I want to override the port level configuration with the user role level configuration, because the user role is enabled with usage. So with that the PoE configuration is done. So let's try to enable security on these two ports. So these are MAC authenticated clients, so I'll try to enable MAC authentication on this interface. So now let's see the interface level configuration. So it is colorless port configuration. So I have not enabled any other configuration apart from the MAC authentication enablement. So let's see the clients. So we have the AP onboarded in the AP rule. So let's see the show power over Ethernet. So this is the global show command. So it will display the total PoE power available as well as the current power drawn from the payee device. So 600 watt is the total available PoE power. The power drawn is 9.77 watt currently. So let's see the device onboarded details now. So we'll go to the AP specific power over Ethernet information. So I will issue the command show power over Ethernet of the AP port. So if you could see here, the PoE allocate by is configured as usage, but allocate by actual is happened via LLDP negotiation. So even though we have the rule configuration as PoE allocate by as usage, but the LLDP negotiation only takes the precedence. So for that purpose now we have to disable LLDP on the switch. So the LLDP negotiation will not happen. So let's see the show port access client's output. Now the phone is also onboarded. We'll see the power over Ethernet information for the both the AP port and then the phone port. So for the phone port, it shows allocate by configured as class, but allocate by actual is happened via LLDP power negotiation. So this also shows even though the role-based configuration is present, the LLDP negotiation takes the precedence and both the end devices as negotiated the power using only the LLDP negotiation. So you can use the show power over Ethernet brief show command also to view the actual allocation. So if we could see here, it clearly shows the power drawn and then the PD status. So we'll disable the LLDP for that purpose in the switch. So the LLDP negotiation will not happen and save the configuration. Let's check whether there is any LLDP information. Since we have disabled the LLDP, there won't be any LLDP information. So now we will go to the interfaces and then toggle both the power and then the data part. So I will be doing the no link PoE for that purpose, and then we'll try to enable the PoE and data again via the link PoE CLI command. So let's see whether the client got onboarded. So the client was not yet onboarded. We'll wait for a few seconds for it. So now the clients has onboarded. So let's see the power over Ethernet information for both the end clients. So if you could see here, the allocate by actual has happened via class and usage, that is based on the role configuration only. Previously it was via the LLDP negotiation, now it is via the role configuration. So show port access rule will confirm the same. So for the AP it is allocate by class, and for the phone it will be allocate by usage. So let's see the role configuration of the phone. It is allocate by usage. So it is now confirmed, like based on the role configuration only the PoE allocation has happened instead of via the interface level configuration, because for the phone port we have configured the allocate by class, but we have overwritten it with allocate by usage in the rule. So this is evident only based on the role configuration. The PoE allocation happens when there is no LLDP negotiation. So far we have used local user role for the PoE allocation. Same holds good for the DUR. Now let's see how this can be achieved using vendor specific attribute. So for the LUR, we will try to configure the LUR attribute in the enforcement profile. Now for the same enforcement profile, I have tried to change it as vendor specific attributes. So I will try to use the vendor specific attribute newly introduced, that is Aruba PoE allocate by method. So it holds two values, one is class and two is usage. So for the AP profile, I will set it as one, that is class. Next for the phone profile, I will set it as usage. So we'll go to the phone profile and we'll modify from LUR to the vendor specific attribute here also. So we'll try to call the vendor specific attribute, that is PoE allocate by method. So I will set here as usage, that is value 2. So we'll save the enforcement profiles. We'll go back to the switch and then toggle the power of those interfaces. So the clients will get onboarded newly. So we'll do no link PoE and then link PoE to bring up the clients again. So let's see whether the clients has onboarded. Not yet, we'll wait for a few seconds. So now the clients has onboarded. So let's see the role assignment for these clients. So if you could see the detail here, the Aruba PoE allocate by method is set as class for the AP, and for the phone it has been set as usage. So let's see the power over Ethernet information again. So it clearly shows the allocation is actually happened via the vendor specific attribute, that is it has been set as class for the AP and usage for the phone. So based on that, the power allocation has happened successfully. So let's see the interface specific configuration as well. So for the AP, it is via allocate by, actual is via class, even though the allocate by configured is usage in the interface. So next, let's see for the phone port. Here also the allocate by configured is class in the interface, but actually it happened only via the usage, that is the vendor specific attribute assignment. With that demo, we have come to the end of this session. So thank you everyone for watching this video. If you have any further queries, do reach out to us in our AREDS community channel. Thank you. Bye.